And welcome to the Daily Space Weather Show. We've got a coronal mass ejection impact happening. That one was perhaps moving a little bit faster than anybody forecasted, as well as a possible 3 more, but at least 2 more on the way. We'll cover it and lots more tonight at the Smash News Network, least busted name in news. And thanks for tuning in, friends, foes, and neutrals. I'm your host, Dan, a.k.a. Smash-O-Mash. These are 24-hour videos. And there is a massive CME popping off in that southeastern limb. So that is a 24-hour video. Here are just the past couple of hours. And there you can see from the GOES 16 SUVI's perspective, a bunch of plasma is exiting the corona as we speak. So I suspect that will be a third one that is on the way. It's a little bit too early to really tell. Let's briefly zoom out to show you the time and date stamps. There you go. And just an uptick in solar activity in general. Once again, going into tomorrow, the likelihood of additional coronal mass ejections is nearly 100%. So there's our 94 angstroms wavelength. Just classic. And again, big upticks in activity here. We still do have this massive filament that we named after one of our viewers. More about naming filaments later in the video. Follow the hashtag #NameThatFilament on Twitter is how to really do it and monitor the names of filaments. That one is hundreds of thousands, if not 500,000 kilometers in total length. An absolutely massive arch-shaped filament. Shout out to our viewers from St. Louis, the gateway to the West. And we'll cover lots more stuff here. And before we get to what's going on planet Earth, here's a 24-hour video with our favorite wavelength, 171 angstroms. Not half bad. And let's zoom in a little bit here. Yeah, good times. So, folks, what can I say? If you were worried about the sun shutting down and seeing 2 really weak solar sunspot cycles in a row, you can stop worrying about that now. If you were worried that that was the end of the world, or if you're rejoicing that was the end of the world, well, unfortunately, you'll have to stop rejoicing because not shutting down. Radio flux now approaching 200, and we're still like 6 months out from solar maximum. So, these are facts about the solar cycle. You don't often see a very long one or a very short one. Really, you never see one that's off by more than about 1.2 years. So, it's quite a precisely repeating cycle, the solar sunspot cycle, at least according to the geologic records. So if you were worried that that's a grand solar minimum, then you should stop worrying because we've got 0 weak solar cycles in a row. You should be happy if you thought the grand solar minimum was going to cause the end of civilization. But I guess some people are pretty misanthropic these days. What can I say? And by the way, if you're misanthropic, press the like button anyway and help keep the channel in existence. Press like, press comment, share, hit us up on social media, etc. We're all over the internet at Smash-O-Mash. And Smash News Network. You've reached it. It's the least busted name in news. Bringing you your daily space weather content, the most comprehensive in the world, with the most detailed solar imagery in the world, and 0 nonsensical propaganda to accompany that. Cheers. And check out this fantastic scene in Iceland. What an absolutely surreal place the island nation of Iceland is. That is certainly on my bucket list. Everything from hot springs to active volcanoes to insanely gorgeous gravel cycling routes. And we would show you the volcanic activity, but it's very foggy there, so not really seeing anything except a bunch of fog. Although you'll be seeing the aurora when things clear up there, most likely, as we've got geomagnetic storm conditions on top of all the other stuff that I've already mentioned. So these are the other volcanoes that are erupting. We'll briefly look at what's going on planet Earth before we get back to space weather. Abiko is producing a 15,000-foot ash plume just like Ibu. Luotobi also exploding, and also Strombolian volcanic eruptions. Also Luotolo, Semeru, Dacono, Fernandina continuing to slow down there, but still some more new real estate being created for the nation of Ecuador. Santiaguido, congratulations Ecuador for the new real estate. Santiaguido also exploding in Guatemala, Fuego, Nevado de Ruiz, Sangay, Revenador, and Sabancaya. Earthquakes are next. We've had some rather troubling looking earthquakes in the past couple of days, or the past 24 hours in fact, including a 5.9 at Japan. Let's hope that's not a foreshock. That 5.9 there, was it on land? Nope, not on land either. So that doesn't make things any less troubling, does it? You know, because of the possibility of generating tsunamis, if that is a foreshock. Let's hope not. Vanuatu also had a 5.0 at nearly 400 kilometers, estimated depth for that 5.0. Kamchatka had a 5.0. And Guam had a 5.5. Philippines had a 5.0. So lots of quakes in the West Pacific there. Again, the possibility of a foreshock. Remember, folks, any earthquake can be a foreshock. And let's get back to space weather stats. The 10.7 centimeter radio flux now at 199 solar flux units. 199 is the 10.7 centimeter radio flux. The most proportional set of data to sunspot number to illustrate a sunspot cycle. There you can see the past year. Sunspot number depicted by the red line. Radio flux depicted by the black line. Radio flux now 199 as we're approaching. Let's see, I guess we're already at the fourth highest peak throughout solar cycle 25. And it looks like we'll have an uptick in sunspot number once again tomorrow. Let's take a look at the forecasts here. NOAA forecasting geomagnetic unrest conditions starting early today and going through Thursday. So that's NOAA's forecast. It looks like they're missing one of these CMEs, but there's their Enlil spiral. ESA has not missed it. So ESA is on the same page as us here. And of course, their Enlil spiral has a little bit higher resolution than NOAA's. Here's ESA's Enlil spiral, and they're actually forecasting that's 2 CME impacts and a coronal hole high-speed stream. So we'll see if there may be a co-interacting region here showing up around the same time as the initial density shock wave of that coronal hole high-speed stream. So there could be 3 CMEs. So we see 2 on the forecast. It may be too early that they have not updated it yet, but we'll let you know tomorrow if ESA thinks that there may be 2 more headed this way, so just keep that in mind. Anyway, we do have geomagnetic storm conditions. Like I said, here are the past 4 hours of Earth magnetic moment from space, and we're going to show you a pane that we don't normally show you. Ways to check and see if the aurora might be visible at your location. So we may see aurora here at mid-latitudes. It's always a possibility when you have CME impacts. Again, that's the last 4 hours of Earth's magnetic moment from space. Now, here's our geoelectric field map, and this is showing actual induction into the power grid. So we are seeing some significant power grid induction here in the past few hours. So that is one way you could tell if the aurora are likely to be visible at your location. It is the geoelectric field models for US and Canada, empirical data, actual data from induction into the power grid. Really, it's power grids because there are like 3 or 4 of them there. 3, 4, 5 of them, something like that. But there's all the data. So when you see your location lighting up, if it's dark out and you've got clear skies, go out and look up. Break out your digital camera, your digital video recorder or whatever, and get it set to the correct settings and see if you can capture the aurora. If you think you're seeing the aurora, use your camera. Your camera will assure you whether you're seeing the aurora or not. So we may have multiple events on the way, at least 3 CMEs on the way, and I think it's going to be 4, but at least 3, and a coronal hole high-speed stream. So here's our ground magnetic perturbation map. This is Earth's magnetic moment from the ground level. And those spiral-looking features there, those are the polar views. That's Earth's B field, changes to it in magnetic flux density, the units of which are nanotesla. So there's that. Here is the full Earth map. And you may get some great substorms in South America. Yeah, Bruce. Hey, Bruce, in Brazil. You may get to see the aurora here. It's not really what you'd call a substorm. It's just kind of a geomagnetic storm. So as you can see on the map there could be some aurora over the central equatorial Pacific Ocean. So KP index at 5. So it's already a geomagnetic storm conditions there. KP5 is where we currently are. So some strong fields here showing up, just subsiding here. So we had a pretty good signal there for the last several hours. Since then, the signal's going to pot at the ACE. So it looks like the geomagnetic storm is subsiding according to that data. Let's check out the Discover. And indeed, the field is weakening as well as moving toward positive. So that upper right there, where it says 9 and -4, that's the 9 is the nanotesla. 9 nanotesla is the total field strength of the solar wind, and then -4 is the negative BZ. That's the vertical component. So still somewhat of a vertical component there, but it looks like it's weakening. Now we also are seeing a little uptick in the density. So density now at about 18 protons per cubic centimeter. Solar wind speed here still kind of low at only 368 kilometers per second. So that looks like it... I'm not so sure. If that's a CME impact, it's pretty slow. There is a slight signal here just in the past few hours, though. So that's definitely a different magnetic regime. You can see a change in the plasma temperature on that bottom frame. Solar wind speed here, just a couple little spikes. Still kind of slow, but a lot denser than it was, although the magnetic fields are weakening. So yeah, it looks like the geomagnetic storm conditions are subsiding, if I had to guess. And here you can see some variations happening in the GOES magnetometers. No real surprise there. It's been geomagnetic storm conditions, so what can you say? Also some maneuvering being done there by both the GOES 16 and GOES 18, marked by those arc jet moments. Those are shown on the graph because when they use their thrusters, it creates plasma, which can affect the magnetic field measurements. Earth is still in a South Pole magnetic sector as far as the heliosphere magnetism goes. There it is, South Pole sector. You can expect Earth to remain there for days. Here's our line-of-sight field plot depicting the solar magnetism, the photosphere in grayscale, polar fields in red and green, and the solar B field in blue. That's a lot of info, 4 days worth, all at once. Here's our line-of-sight coronal hole plot, and these videos are kept very dense with data. Moving right along to view coronal holes from SDO's perspective. And there you go. That's we've got it's dear God, what has happened? Dear God. So yeah, we do have coronal holes rotating in here. That's creating the possibility of co-interacting regions. And as we've said repeatedly on the channel, you can expect coronal hole activity to continue to pick up because we've really had a shortage of coronal holes throughout solar cycle 25, Which brings us to sunspots. Sunspots. Now the sunspot number is just under 180. So 179 sunspots with a radial flux of 199. That is not an inactive star. That is an average star at least. And here is our flare probability monitor and scoreboard. So we've got multiple locations where we could see a large solar flare, folks. I'm just going to let the imagery speak for itself. If you have any questions about it, just leave a comment, and either our viewers, Smash staff, or I will answer your questions. Some very likely high spots there. Some very high likelihood locations there for an X-class solar flare. And it is especially sunspot 3639. So we'll show you some imagery of that. Here is our magnetronic magnetometer. It uses polarized light to determine the magnetic fields at the photosphere level. The photosphere could be described as the solar surface, depending on if you consider that to be blasphemy or not. And we'll have another uptick in the sunspot number tomorrow as it approaches 200. So there is our SDO continuum. And yes, we've got a conflagration of additional sunspots. Several have risen in the northeast. Looks like it could be 2 more new named groups there in the northeast. So yeah, sunspot number to rise once again tomorrow by at least 15. So yeah, sunspot number will be getting very close to 200 by tomorrow, assuming nothing rapidly changes. And it can rapidly change. And let's move on to flares and energetic particles. So as far as SEPs go, we ain't got no SEPs. We haven't had solar flares from the right locations or with the right magnetic orientations. So here is our flare situation for the past 3 days, and only one M-class event here. Again, the likelihood of large solar flares, very high. Likelihood of coronal mass ejections, nearly 100%. And don't get the two things confused, folks. We hear it all the time. People saying, oh, when's the flare going to get here? When a solar flare is detected, the flare is already here. A solar flare is photons. X-ray frequency photons. A coronal mass ejection is when material blasts out of the sun's atmosphere, which creates things like geomagnetic storms, the aurora borealis, induction into the power grid, induction into pipelines and railways, things like that. The one is coronal mass ejections. The latter, the former, is solar flares. Those are X-rays. X-rays are completely different than gaseous plasma blasting through the solar system. You see what I mean? Solar flares are photons. Coronal mass ejections are protons. Don't get them confused because they're completely different, separate phenomenon. And before we get to a star chart, let's take a look at sunspots, and and there you go. It's the past 24 hours, SDO 131 angstroms, and that M-class event was from I think that's Southeastern Sunspot Group. But I'm not entirely sure, so I don't know what to tell you. I'm not entirely sure, so deal with it. It's elementary, my dear Watson. Is that a thing? I don't know. Anyway, here's your solar system forecast. This is where things lie today, and this is a channel that doesn't lie about space weather. So here's your 1 week solar system forecast. There's where things will be in a week as Mercury speeds away and Venus plays catch up, which it'll be doing for another couple of months. Next is our star chart from skyandtelescope.org. We like to show what's going on over our head as we're unable to show you what's going on over all of your heads because it's all different. But we do have the sun in ascending mode there. If you're up before dawn and you have clear skies, you may see Mercury just behind Venus. So yeah, tomorrow will be a great day to view Mercury rising if you've got clear morning skies. You'll also have Saturn and Mars rising ahead of Venus and then Mercury. So yeah, it'll be an interesting sunrise if you want to go stargazing late tonight. Now our astronomy photo of the day, apod.nasa.gov, is the Vela pulsar supernoval remnant. So around 11,000 years ago, just around the dawn of civilization, or the most recent dawn of civilization, or whatever you want to say, a strange brightening occurred around the galactic disk where this massive supernoval remnant, as it's called, was produced. And you can still see the shockwave from that to this day. It was caused by an event that is associated with this little object right here. That is the Vela pulsar. So it's a little animation there of the Vela pulsar. The Vela pulsar has a pulsar wind nebula. That is that arc-shaped feature behind it. And you can see a relativistic jet blasting off in somewhat the opposite direction, and another relativistic jet likely oriented more toward Earth, but not really directly toward Earth. It's just giving us a great perspective there of those two polar jets. So Vela pulsar rotates at approximately 10 rotations per second, I think it is. Something like, 10 rotations per second. And the Vela pulsar, one of the more interesting objects visible from planet Earth. apod.nasa.gov if you want a great image. And that's a bunch of different wavelength spectra there. That is a series of different chemicals, including probably hydrogen. The blue is probably oxygen. That's usually what it is. And there could be some heavier elements in there also, like sulfur. Not exactly sure there. I don't think it's going to show exactly what all the spectra are. But a lot of image credits there from several different organizations. So that'll give you some insight if you want to look it up as to what those spectra represent. The Vela Nebula, the Vela supernoval remnant, I guess we'll call it, for sake of understanding what it is. The Vela pulsar, a very interesting object. Next, moving on to CMEs, and we got them. And again, I think there are two more headed this way. The most recent one is the one that we showed you to start the video out from the southeast. There was another one earlier than that that's also from the southeast. That likely does have earthly directed components, so exciting stuff for space weather continues. Yes. Exciting space weather action. You gotta love it. Unless you don't, then you don't gotta do anything. So, but earlier today... Sup with that? Yes, very early today. So that one there out of the southeast, I think that has an earthly directed component. And the one that's popping off now, we think has an earthly directed component. So that just became visible early this morning around 5:30. Yep, because of where it came from, the southeast. So we'll also show stereo A and its difference imagery. Let's check that out around 5 o'clock this morning. And do you see it? Indeed you do. Yeah, so now it's too early to really actually see the one that is going off now. It's not going to appear in the coronagraph imagery for a couple of hours yet, and we're making the video now, so that's just, you just have to deal with that. It's part of airing the video at 7 o'clock every day. That's 7 p.m. Eastern Time. And before we get to filaments, let's take a look at our custom coronagraphs. Yowzers, they're sweet. You've reached the Smash News Network, least busted name in news. Yeah, so from early this morning, you'll see right in this area right here is where that first CME was generated from. That makes it very likely to have earthly directed components. So that one we can expect to arrive on the 19th. And then there's another one popping off right now from that same general area, which we are expecting to also arrive later in the day on the 19th. So that looks like 4 CMEs and a coronal hole high-speed stream all on the way, which is an exciting, delighting, and not frightening space weather extravaganza. So we'll take it. We're always delighted to see some space weather popping off. And if you get some imagery of the aurora or anything like that, make sure you share it with us over on X at x.com/smashomash, otherwise known as Twitter. You know, we like to call it Twitter since that's an actual brand. So anyway, let's get the filaments. And we're showing the Big Bear ground-based hydrogen alpha telescope today. And we've got more active regions likely to rise in the east. So again, sunspot number will be approaching 200 tomorrow. And look at all those filaments. You'll see one of them blasting off right down here. That one is now headed in our direction. And then a second event from that same area, also likely headed in our direction. So, yeah, good times for space weather. Once again, there are the past couple of hours on the GOES 16 SUVI, and that brings us to bonus features. Satellite charging hazards. But first, a quick note about propaganda. So imagine being a content creator so phony that you can look at 170 sunspots and declare that it's a, quote, grand solar minimum. What? Now imagine being a viewer so susceptible to propaganda that you'd believe such bollocks. The logical leaps required are paying out a lot of dollars in YouTube ad revenue. A lot of people are going to their cult church meetings and just accepting utter nonsense. That's about 180 sunspots. We're going up to about 200 sunspots. The solar cycle is an average solar cycle, at least, possibly slightly above average. So, I mean, you would think people would be less susceptible to propaganda after the past 4 years, but apparently not. Anyway, here come bonus features. We've got some significant satellite charging hazards, so those could cause a little bit of communications errors. Not any damage to the satellites, not any internal errors, but communications errors as low-energy electrons build up on the outside of spacecraft. Quite a lot of them there, so some significant external charging hazards on the surfaces of spacecraft. Southeast Asia, the northern Indian Ocean, India moving into the Middle East. And that may be subsiding along with the geomagnetic storm conditions. I would suspect that it probably is. Here's our GOES electron flux for the past 3 days, and you're seeing that dipping there. That is characteristic of geomagnetic storm conditions. It is an erroneous reading, but it does show us insight into what the ionosphere is doing. That is measured at the F-flare using radiography from the geosynchronous orbits of the GOES 16 and GOES 18. Next is our 1-year graph of the electron flux. There it is. Feel free to pause the video on these frames. There's our forecast model. It looks like NOAA's going to be a little bit above the actual thing there, but we'll see when it updates tomorrow. Next, the layer where it's measured, the F-flare. The F-flare of the ionosphere. Don't be effed. Know where it is. Pause the video on this frame if you're not familiar with the temperatures of the layers of the atmosphere, the ability of electromagnetic radiation to penetrate layers of the atmosphere, or chemical concentrations in atmospheric layers. Here is the vibrational frequency, the ionosonde, for about 300 kilometers of altitude, the F-flare. So we should see some low-frequency anomalies there toward the end of that. That would be consistent with mild geomagnetic storm conditions. Here's the anomalygram, anomaly in megahertz from a 30-day median. And you should see a little bit additional red there, especially in the northern hemisphere, and that's exactly what you're seeing. So, not a real surprise there. As we approach the 1 month into spring mark. So that actually is causing a reduction in the Russell-McLaren effect, so the likelihood of major geomagnetic storms actually decreases as you approach the solstice. And that has to do with the acceleration of relativistic electrons in the outer Van Allen belt. Next is our total ionosphere nowcast, the whole the WAM, the whole atmosphere model. Don't carelessly whisper about it. Just look at the actual data. We've got some major high electron content anomalies over places like the Pacific Ocean. Also the Indian Ocean. Maximum usable frequency shown on the right for all of you radio operators. We'll close out space weather and move to meteorology right after we take a look at these new sunspots. Check it out. New sunspots, that's at least 2 new groups. So that'll be at least 18 sunspots, and it'll probably be a lot more than that. Look at all the sunspots down there. Yeah. Next stop, 200 sunspots, folks. Facts. No matter how inconvenient they get, we'll keep citing them because, well, that's when I stop calling them like I see them, this channel shall fold. In other words, the channel shall not fold. All right, so meteorology is next, and the U.S. weather is absolutely being governed by that massive low-pressure system there just south of Minnesota. So really over Iowa right now, over like northwestern Iowa, a massive low. Now it is largely entrained by dry massive air to its south, so the main precipitation is associated with its northern and easterly portions. Will cover it. But first, the planet's wind patterns. Surface winds of the east. And your jet streams. Shout out to the viewers from the eastern world. Here's the central world. Shout out to our viewers from the central world. There are your jets. There are your surface winds. Some conflicting winds there in the Mediterranean. Perhaps not a great day for migrant boating. Surface winds of the western world. Shout out to our viewers from the Americas. And there you can see that low rotating counterclockwise. And shout out to Smash Staff for being an absolute baller. Here are the jet streams of this side of the planet. We've got a tripled up jet stream over the Atlantic. Some big bends. Some cold air being injected into the southwestern U.S. And some warm air over here in the northeast. We'll take it. It's been gorgeous. Now today we got a cold front. And that cold front made it so cold that it got to like 75 degrees. So just absolutely spectacular weather for April. Just splentacularly fantabulous. There's our satellite imagery for the Americas. And here's our windy.com map. We're looking at snow depth. Let's take a look at new snow for the next 3 days, since there's some fallen. There is your new snow map. Quite a bit fallen in Manitoba. And plenty in Saskatchewan. So yeah, there's a Euro model. There's your GFS model for the snow for the next 3 days. Euro model, next 3 days of snow. And GFS. Here's our weather.gov map. And we've got some severe weather over most of Iowa, lots of Missouri, and also Illinois. We've scrolled down to show you the key, and that's a huge area of tornado watch. I suspect channels that don't understand basic physics will be reading news headlines, as they do every day, and spout propagandistic nonsense. But yeah, there's your map. Here come your forecasts. And we're showing mean sea level pressure and 10-meter winds here because we've got some... Well, we just wanted to show that low making its way up to the Great Lakes where it will evaporate. So it's gonna, that low is going to say, no, I'm not entering Canada. I would rather become a non-low first. So it's going to sort of loiter there for a brief moment over Michigan, and then it's going to fizzle out. That's a 72-hour GFS, mean sea level pressure, and 10-meter winds. Here's pressure and precipitation. Same model, 72-hour GFS. Temperature anomaly. It is temperature anomaly in degrees Celsius for the 72-hour GFS model. A mixture of both warm and cold anomalous temperatures. Not a lot of average temperatures, actually, right now, but April is a turbulent month. Next is lightning. So that's what's going on with lightning. Let me hide this. So yeah, that's what's going on with lightning for the past 10 hours. And here's our real-time lightning map. Again, quite a bit of activity there in Iowa. Give it a minute to connect. And there you go. Like I said, also Wisconsin getting some lightning strikes. Some concentrated cells here. That is a nasty looking storm. Look at all the strikes in that area. That's the kind of storm that could be accompanied by damaging winds and hail. So multiple large, very active cells there being spun off by that low. Massive pressure gradients being created. Just north of Dubuque, one of the strongest cells right in there. Lots of thunder rolling in. Yowzers. Jeebus gond of a criminy cripes. Jeebus gond. All right, so there you can see that low, and the heaviest rains here just passing through Minneapolis. There'll be continued rain in Minneapolis for the coming hours, but the heaviest rain is now behind you, to your north. Those strong storms here are going to make it almost due north. Wisconsin's going to get kaplastered, and it's going to be some high seas for the Great Lakes. The Great Lakes Triangle, vastly more dangerous than the Bermuda Triangle, statistically speaking. Now, keep in mind that is because there's a lot of shipping in the Great Lakes Triangle. But nonetheless, facts. U.S. Doppler radar. Facts. Satellite imagery. Visible satellite. And the water vapor map. And there, like I said, you can see that entrained dry mass of air. That's helping to give it a little bit of an impulse to move it to the northeast. However, it's also creating massive pressure gradients there as the dry air pushes around the moist air, and the lows, they attract the surrounding air to them. Lows suck and highs blow. Anticyclones, they are associated with high winds, and so are low pressure systems, but for different reasons. One is a pressure on the atmosphere from above, and the other one is a lifting of the atmosphere, almost as if it's being levitated. Very different scenarios, a low and high pressure, despite them both being associated with wind. Anyway, here's your recap U.S. Doppler radar. Highs blow and lows suck. There's visible satellite once again, and there is your water vapor map, which should clear things up if your Doppler is unclear. And here, let me clear something else up. This video is complete. Thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind, the incoming solar storm activity, be at your back while I go back to the bunker. I'm going back to the bunker again. Whoa.